This is 5.2, part 2, the long-awaited conclusion. 5.2. We got to finish up 5.2. So we're wanting to find the LCM. LCM. So you look at this guy and you look at this guy, and you're saying, okay, what do we got to do first? Factor, which is what today's test is on. So this is reinforcing what you're going to do today. Can we factor both of those? How do we factor this first one? Take out y to the third, leaves y squared plus 16. We good there? Now how do we factor the second one? Take out a y, leaves y squared minus 8y plus 16. And then we can further factor. Good. Remember all this about factoring? So I'm trying to factor now the y cubed minus 8y squared plus 16y. First step is I took out a y. And then I do the double parentheses from there. That good? Because that multiplies to be plus 16 adds to be minus 8. Minus 4 and minus 4 add to be minus 8, and they multiply to be plus 16. What do you do with identical twins? Good. And now I didn't finish factoring that other one, right? How do we got to finish that up? Y squared plus 16? No. Good. You know it's a no-go. It's not y plus 4, y plus 4. Remember how we talked about that? The plus double cannot go further. Only the minus. So that one's just going to stay y cubed times y squared plus 16. You can't do any more with that y squared plus 16. So there's the first one all factored. There's the second one. So most of the work is factoring, which is today's task. So is that good? A little review there of factoring again. Now, let's find, now that it's all factored, this is actually the easier part, let's find the LCM. Now remember, how do we do the LCM? Remember we go shopping? I made an analogy with shopping. It's like going to Costco saying, I'm going to buy one of everything today. I'm going to buy, and the most expensive, I'm going to buy the most expensive shampoo, most expensive pair of shoes, the most expensive whatever. So I'm going to buy one of every type. So LCM is one of each type, highest power version, most expensive, right? That's why I'm saying most expensive, highest power. So when it comes to plain y's, I've got a y cubed and a y to the first. Which one am I going to buy? Y cubed. When it comes to y squared plus 16 packages, remember they're glued together. You don't separate y squared from 16. The plus and minus is glue, right? Y squared plus 16 package, well, I just need it. There's only one of them, I need it. What other packages are here? Y minus 4, and I got to take squared. That's the only package. There we go. That's the LCM. Does that make sense what I did? I just went down the aisle. I went down the green one, down the purple one, taking one of every type, the highest power version. Right? I took the solo y, right? There's a solo y that's not glued to anything. I took y cubed instead of y to the first bracket. I take the highest one. And then I take the y squared plus 16 package. I take the y minus 4 squared package. Every package, highest power. Is that good for LCM? Questions on that? All right, I better. All right, so number 16. So now we're adding and subtracting big, ugly fractions. That's what the rest of this section is about. So how do we subtract those two fractions?
The denominator is the same.
Yeah, they've already got common denominator, huh? So you just keep common denominator. Think about like 7/9 minus 2/9. What would you do? You just make it 5/9. So you just keep common denominator. Say you had just numbers. So it's the same thing for letters, isn't it? The rules are the same. So let's subtract the top. Can you do that? Go ahead and subtract the tops. keeping the common denominator. Because there's a little trick. I want to see if you notice it. So it's going to be 3x plus 5 minus. The trick is you've got to parenthesize that x minus 6 because you're subtracting the entire x minus 6. It's going to go like that. So we're going to get 3x plus 5 minus x plus 6. And so that's 3x minus 1x is 2x. 5 plus 6 is 11 over x minus x. There it is. Are we good there? So watch out for that. It's a really easy mistake to make. When you have subtraction in the middle, it has to distribute to both of those. You good there? All right. On 17, they have these guys reversed, right? I want to write that one down, and we'll talk about it. But see how they have them reversed, opposite order of subtracting there. So we can't have that. We can't have them in opposite order like that. We have to, it doesn't really matter which way you go, but you have to have them the same. So I just always put the earlier letter in the alphabet first. So I want B to come first. So I like the way the first one is. I'm going to turn around the other one. So you could actually do it the other way, it'd be fine. Anyway, so I'm going to turn this one around. Now, what happens when you flip something around that has a minus in the middle? Yeah, you've got to change. You got to put a -1 in the front. Remember that? It's called the turnaround rule. The way I said it before is I said if there's a x at the back, so I've got to turn this around and put a -1 in the front. Does everybody see what happened there? That's the same thing. To actually flip it, so let me write a note here. So you turn around and -1 in the front. So you turn it around and you put a -1 in the front. So you turn it around so it's B minus D and you put a -1 in the front. That's actually the same thing. You could check it out. You don't have to, let me just show you. You don't have to do this, but if you multiplied it out, you see what that is? That's the same as D minus B. See how the B is negative, the D is positive? It's the same thing. To both flip it around and put a minus in the front really does nothing. It just looks different. So it's a legal change, right? It's not really changing what it is. It's only changing how it looks. Now, I don't want that -1 on the bottom. Why not? Because I want a common denominator, right? I want just B minus D and B minus D. I don't want some other -1 thing there. So what can I do with that -1? Let it travel to the top. You know that a negative on a fraction doesn't matter top or bottom, huh? If you have -2/7, that's the same as 2 over -7, isn't it? Doesn't matter where the negative is, so I can just let that negative go from the bottom to the top. So I will do exactly that. So it'll become B squared over B minus D plus -B squared. And now that negative has left the bottom. Does that make sense what happened there? It's a little trickery with flips and movements. Why am I doing that? I want to make the bottoms exactly the same. That's always the name of the game, huh? Common denominator. So I flip that around, put a -1 in the front. That's called the turnaround rule. We'll do that a lot. Make sure you're aware that if something is subtracted out of order, flip it around and put a -1 in the front. We'll do that a lot. And then move it up because you don't want anything in the denominator. Now the denominators match, don't they? Common denominator, so now I can just combine them into one fraction. Once the denominators match, you may combine them into one fraction. So it'll become B squared minus D squared. Is that good to there? Everybody see what happened there? It was plus a negative, but that's just minus, huh? Good to there? Is there more we can do? We can cancel the B's. Cancel the D's. B minus D. Can't do that. Why not? Costco says no. Right? You with me? That rule's really important. Right? Plus and minus things are a package deal, which means you can't buy just part of the package. The b squared minus d squared and the b minus, they're both packages. Which means what? Which means if you want to cancel something there, you go like that and cancel the whole thing, or you don't touch it. Same thing in the bottom. All or nothing. Right? Not part. Not part. So I can't, no, I just want the b part and leave one of the b's out. No. You can't go to Costco with your scissors. I just want one spaghetti sauce. Can't do that, right? Costco says no. So, okay, well then, put it back the way it was. So we can't do that. So it's b squared minus d squared. Well, what can we do then? Yeah, the top is actually factorable, isn't it? The top is a difference of squares. B plus d, b minus d, over the bottom, which has not changed. See how that top becomes b plus d, b minus d? And now, because I'm buying the whole package, Costco's fine with that. So the answer is just b plus d. That's all that's left, huh? That one really simplified, didn't it? That making sense? How you doing on all those little maneuvers? So this takes time and effort. You got to practice this, go over and over and over and over this. So again, I flipped that around, and I did the turnaround rule right here. We'll do this a lot. Whenever things are subtracted out of order, we turn them, and we put a minus 1 in the front. Then I let that minus go to the top. Then I had common denominators, so I made it one fraction. That's the whole goal, right? Make the bottoms match. Then you can make it no longer two fractions, but one. Once the denominators are common, you put them together into one fraction. Then I factored and canceled from there. All right. All right, so try 18. What do you do with that minus on the bottom with that y? Move it up, right? Go ahead and move it up. And then you'll have common denominators. They'll both just be y, and you can make it one fraction. Take that minus, move it up. You get to there. Common denominator of y, right? Now I can go from two fractions to one. And so what do? 1 minus 4. Which is what? That's 1 plus 4. Which is 5 over y. We good? All right. How about number 19? What are you going to have to do with that right there?
Reorganize it.
Flip it around. And what happens when you flip it around? Minus 1 in the front, and then let that minus 1 go up top. And it'll hit both of them. Well, you know what I do? Actually, let that minus just hit the minus in the middle. Become plus. That'd be the easiest one. Am I making any sense there? So I did the turnaround here, huh? Everybody see what I'm doing there? So I did the turnaround. I flipped those and put a minus in the front. You can't just turn around. That would change the problem. If you just flipped them around, you can't just flip. The order of subtracting matters, doesn't it? You ever thought about that? I'm sure you know that. When you subtract two things, like if I go 7 minus 3, that's not the same as 3 minus 7, huh? You can't just be changing the order of subtraction. You know that 3 minus 7 is not the same as 7 minus 3. But what is it? Are they like totally different answers, like 12 and 15? No. It's negative 4 and 4. They're only different by a sign, aren't they? So when you switch the order of subtracting two things, it only changes the sign. That's why we put the extra minus 1 out front to fix the sign we just changed. Get the idea? That way, really, we're not changing anything, really. That's why we do all that. That's called the turnaround rule. Know that. We do it a lot. Switch the order of subtraction, put a minus 1 in the front. Right?
And
that,
3 minus z, they're always together because of that negative.
yeah, they're glued together. Right. So, yeah, now what should I do with this negative? I don't want it in the bottom. Let it come up and let it hit this other negative. Because that negative is all, you might wonder, well, that negative is in the middle. No. Remember, that's this guy's baby. Right? Any signs in front of a fraction, a number, a letter, whatever, that's their baby. That's their negative. Even though it's sort of in the middle, it really belongs to that fraction on the right. So this minus goes up, and there's two minuses right there on the fraction to the right, making plus. So that'll be 9z minus 27 over z squared minus 9 plus 3 minus z over z squared minus 9. Everybody see how that became plus? And now, what do you have? Common denominator. That's always our goal. Make the bottoms the same. Now you can combine them into one fraction.
So when it's a plus, the sign don't change.
Yeah, there'll be no changing of signs.
If it was a negative,
If there's
then
a
it would
negative,
change.
then you would change both signs. Yeah, that's right. So now you can just add them up, right? So can you combine those into one fraction now? Everybody see why it became plus? Because when I did the turnaround, I had to put the minus in the front, and then I let that move up, and it hit the other minus.
Right, it's sign doesn't change the sign for
Sign for what?
C.
Sign for.
It's just like I asked you what.
Oh yeah, no. These two are going to hit here. I didn't let the minus go up there. I could have. There's options. Do you know what I mean by that? Like if I had, just think about normal, if I had 7, I had a negative here over negative 3, and I said, I want to get rid of that negative. There's a couple things I could do. I could just move him out front, and then 2 negatives would be there, and that's positive. Or I could say, no. I want to just move that minus right up there instead. He'll be right there. Okay, and then, again, 2 minuses plus. Same answer in the end. Do you see what I'm saying? There's options for where you let that minus go. It's got to go somewhere. And I'm saying it's easier to just let it go to the front. Don't let it go to the top. Because that's a mess. There's 2 terms. You have to distribute. It's easy to mess up. Just put it in the front. So I just said, I'm only putting it right here. I'm not letting it go into the 3 and the minus z at all. Because that's just easier. Does it make sense? It's just hitting the front of that fraction. The 2 minuses make plus. Now you combine those, right? Now you can make them one fraction because they have a common denominator. So put them together. Remember, I turn this around, then this minus came right there and hit that other minus. 2 minuses made plus, so we ended up with 9z minus 27 plus 3 minus z all over common denominator, right? So I can do one fraction now. Don't need 2 anymore as soon as the denominators mesh. So what does this make? 9z minus 1z, 8z minus 27 plus 3, minus 24. And then can we do anything more at this point?
Yes.
Factor. Today's test is all about factoring, huh? Can you factor the top and factor the bottom? How do you factor that numerator? How do you factor 8z minus 24? Take out the 8, huh? How do you factor the denominator? Z plus 3, z minus 3. These cancel. Final answer, 8 over z plus 3. Good. It's making good sense. Questions I can answer? Claudia.
Okay, when you changed that negative 1, when it was a negative up there, and then we just changed it to positive, how
talking about right there?
Had it been a positive and we're changing it to a negative,
Yeah.
do we have to change that negative z to a positive z? Or it's just,
Yeah, we would have to because we would be subtracting the whole quantity. We would do it like we did this one, Claudia. Remember this one right here? We just wrote minus, we put parentheses, and then it eventually changed them both. See, when there's minus left over in the middle, that's because that's what you're basically asking. What if we had a minus left over in the middle? Then we would just write minus and we'd put parentheses around the upper right and then it would eventually distribute to both, like minuses always do, in front of a group.
and when it's a positive,
It still distributes, but what does a positive do? A positive doesn't change anything. So everything distributes, but pluses make no change when they distribute, so we kind of ignore them.
all right,
But everything distributes.
okay,
Minuses show their distribution by making changes.
all right.
That's the difference. Yeah. Is that good? So we'll get to some minus ones. Okay. So yes, this is going to be more of a big one here. So I'm going to give you some steps now for handling this. How do you add, subtract, fraction? So this one's going to be more full-orbed. It's going to take all that we've got. So number one, factor denoms. You got to start with factoring denominators, meaning that guy. That part needs to be factored first off. So this is good practice for today's test. Can you factor that? Let me let you go ahead and do that. So factor that denominator over there, that x squared minus 49y squared. How does that factor? X plus 7y, x minus 7y. Difference of squares. Is that good? All right, so that's step one, factor denominators. Now, step two, multiply top, bottom by what is missing. Give them what they're missing. Because what's our goal here? We want to make the bottoms the same, right? We got to make those bottoms the same. So to make those bottoms the same, I got to come over to this guy and I got to multiply top and bottom. This guy's missing something that the other denominator has, right? What's he missing? Yeah, he's missing the x minus 7y. Does everybody see that? So you multiply top and bottom. No, now I'm doing the top and the bottom. So that doesn't change anything. I'm not changing that fraction. You can always do the same thing to the top and the bottom of a fraction. You're not changing anything. So that, and notice the two denominators now. They're the same. I made the bottoms the same, huh? Everybody see that? They have the same two pieces, don't they? They both have an x plus 7y and an x minus 7y. The two denominators are the same. Which means what? Which means on the next line, I'm going to make it one fraction. No longer two. Because the two denominators are the same. Right? The two denominators are the same. Okay, step three. So you're tracking with me? Step one, step two. Step three, multiply the tops and gather like terms. Only in the, by the way, we're done with the denominator at this point. I'm not going to do another thing. Because you might wonder, should I multiply? A good question would be, should I multiply out the bottom? No, we're done. Once you've made common denominator, you're done with the denominator. That was our whole purpose with the denominator, to make them common, same. Once you've done that, never touch the denominator again. Now, all my attention is going to turn to the numerator. All the rest of the work is up top. So now in the top, so the first two steps are all about the denominator. factoring denominators, making the denominators the same, and then the third and fourth steps are all about the top. Now you move to the top. Just say, okay, I'm just going to take the top, 28xy, and then this, I'm going to FOIL this out. I'm not multiplying the bottoms, but I am multiplying the tops. X squared minus 7xy. Boom, boom. Minus 7xy plus 49y squared. So everybody see what happened there? All of this became these four. Y'all see that? I just FOILed that out. X minus 7y times x minus 7y. It became all of that. And then here's the other piece. So these get a little messy. It's a big section. A little messy. You doing okay?
Where did you get the 49 squared?
Minus 7y times minus 7y made plus 49y squared. So I just literally just FOILed that out up there. I just took the x to both of these guys, and then the minus 7y to both of those guys. First to both, second to both. So that's multiplying the tops. Gather like terms now on the top. I'm going to start with the x squared first. Just going to put them in order from highest power to lowest. Now there's two letters, so you got to pick which letter. I'm just going to put alphabetically. X comes before y. So x squared, 28xy minus 7xy minus 7xy. That's like terms, huh? 28 minus 14, basically, is 14xy plus 49y squared over common denominator x plus 7y x minus 7y. Are we good to there? Now, last step, step number 4. Try to factor the top and reduce. I say try because often you can't. Turns out this time we can. You can factor that top. Usually we skip step 4. About 90% of the time we don't have to do step number 4. The top doesn't factor. Usually we're done at this point. But this is a rare one. We can factor that top. See how that top can factor? Can you factor that top? So it's a good question for today. That could be on today's test. Factor that top right there. So can you factor that top? So that top, in fact, I'm kind of running out of room here. That top will factor. I'm just going to squeeze it in. X plus 7y, x minus 7y. Is that okay? It's plus 7y minus 7y. No, I'm sorry. Both plus. My mistake. Both plus. Both plus, because that's how you get a plus 14 in the middle, and they multiply to be plus 49. Right? We're looking for, they have to multiply to be 49, positive 49, add to be positive 14. You got to have y's, you have y squared on the right, so you're going to have y's in the right of each parenthesis, huh? And the bottom stays the same, x plus 7y, x minus 7y, and then these cancel, don't they? And so there's our final answer. It's just x plus 7y over x minus 7y. That was a long problem. So what I had to do to learn math with things like that, I'm sure I did not get that in class the first time it was presented. I would just copy it all down, and I would do it again later. And I would redo it. I would just start from there, blank piece of paper, and see if I could do it. And I never could at first. And I'd be stuck. And then I'd look back at the notes and go, oh, yeah, that's right, you moved the thing. And then I would try again, blank piece of paper, starting from the top. And again, and again, and again, until I could do it. A lot of people aren't willing to work that hard. That's the choice before you. Especially here in chapter 5. I told you exam 2 is the easy one, but it's going to pick up a little bit now. This takes lots of time, lots more time than a psychology class is going to take or a history class. And I'm not putting those down. I love history. If I do again, I do history. I'm just saying math's like learning Chinese or some other foreign language, right? It's just a lot of time. You got to just go over and over and over. That's terrible, isn't it? Look at all that mess. That looks like Chinese the way I write it, right? It just takes a lot of time. But you can do it. I don't mean that to be discouraging. But I want you to know that's what it takes. You have to put hours in and just redo these, look back at the notes, try them again, and you can eventually get it. Questions I can answer on that one?
When you said that minus change the value, but the positive doesn't change the value.
Right, that's the difference. Yeah, because they're both distributing. It's just pluses don't change anything. They kind of invisibly distribute. Yeah. All right, so step 1. Factor. So good for today's test. Practice on factoring. It's our last practice. Factor denoms. Can you factor both of those denominators? I'll put that to you for you. Factor those denominators. So what times what multiplies to be 40? Just use your calculator if you're rusty on some of these things. Yeah, it's going to be 8 and 5, huh? And then how do they add to be negative 3? Remember the sign in the middle always goes on the bigger number, huh? Minus 8 plus 5. Like that. And then the other one, how do you factor w squared minus 25? We've done a million of those, huh? W's in the front, 5's in the back, 1 plus, 1 minus. So step 1, factor denominators. We did it. All right, step 2. What's step 2 now? Is everybody good to there for step 1? What's step 2 now? Yeah, give them what they're missing. Yeah, you know what? Can I make a suggestion? Yeah, I'm thinking about what Claudia said. It's best, those minus signs in the middle, they really mess people up. They're actually, you know, if I was to make a top 10 list, I think that'd be number 1 of common mistakes. That minus in the middle, so deadly. Let's just distribute it right now. I think it's easiest just to get it out of there right now. Because later, it's just going to get messier. And then it's really easy to forget about the fact that what it's going to do. So just let it distribute right now. So yeah, let me say that. I'll just write never subtract. It's hazardous to your health, to your algebraic health. Never subtract. Instead, distribute the subtraction to the upper right all terms. So it'll hit both those. So it'll become 7w minus 1, w minus 8, whoops. Plus and that'll become minus w plus 14. Does everybody see what happened there? Yeah, I would just suggest you never subtract. It's just too easy to mess up. It's the number 1 most commonly made mistake, is forgetting to distribute. So just distribute right away. So minus is in the middle. We'll never subtract. Anytime they have a subtraction in the middle, I'll just let it go to the upper right away. So everybody see what I'm doing there? That'd be like, just to show you that what I'm doing is really a normal thing with numbers. What if I had 8 minus 6? I could say, hey, don't subtract, instead add the opposite. That's the same thing, huh? That's going to be 2 either way, isn't it? That's exactly what I'm doing. See, when I'm doing this with the big fraction, I'm just saying instead of subtracting, just add and make the opposite of all those guys. Right? Just like instead of 8 minus 6, just add the opposite. It's the same thing, isn't it? It's not different. and it's way more convenient, so you won't mess up. So instead of subtracting, add the opposite. That's what I'm saying. Change to adding, and then make the opposite of all those guys. It's really going to subtract. It's just that way you won't mess up. The distribution is done. We don't have to worry about it. Okay, so step 2. What is our step number 2? Top and bottom missing. Remember, give them what they're missing. This is where you it's like comparing to your neighbors, which isn't helpful. Compare to your neighbors. What do they have that you don't have? That's what you're not supposed to do, right? It's not helpful to your life. My neighbor, though, has a very nice car. What is a Mustang GT? It's like really powerful. You hear it rumble in the garage and rumble out. I've got a minivan because I got a bunch. And I think, why does he have a cool car and I've got the minivan? You know? There it is. He's got 1 kid. I've got 5 kids. That's the difference. All right. Anyway, so so don't compare to your neighbors. It's not helpful. But do that with fractions. It is helpful. So we want to make them the same. The neighbor's going to give me his car, and I'll give him a couple of my kids. Right? So we're going to make the denominators common. That's our goal. So what does this guy need? And then what does this guy need? We're going to make them, fill in what the other one has, make them the same. Make the bottom same. So what is this denominator missing that the other one has? W minus 5. So, and you got to do the same thing top and bottom, so we're not changing anything, right? So W minus 5 top and bottom for the left fraction. What about the right fraction? Yeah, the W minus 8 is missing. W minus 8, W minus 8. Top and bottom. Now the two denominators are the same, aren't they? Right? This and this are exactly the same. We've made common denominators. We're done with the denominator now, right? That was our big goal. So I can just make it one big fraction. Doesn't matter what order you put these in, as long as you got them all. Those 3 are the common denominator. It's what both denominators have, huh? We good to there? Now all of our attention turns to the top. Multiply the tops, huh? Now you just go, okay, FOIL and FOIL. We got to get to our test here, but FOIL and FOIL. So I'm going to get, so you just got to be careful here. Just easy to mess up. It's a lot of foiling. Am I racing ahead of you? Are you good? You see how this process works? Give them top and bottom, what's missing, and then FOIL it out. Watch your signs carefully. And then minus W plus 14 is going to distribute. Minus W squared plus 8W plus 14W minus, it's at 80 and 32, 112. That's 112, is that right? See all that? See the 4 red terms that came from this right top and the 4 black terms that came from the left top. I just FOILed them both out. Multiplied out the tops. Is that good? On the tops there? Everybody see what happened? Just big, ugly mess. So now we're just one step from the end. Just combine the top, right? 7W squared minus 1W squared. 7W squared minus 1W squared? 6W squared. Use your calculator. Minus 35W minus 1 more. Be minus 36 plus 8. What is that? 28. Minus 28. Plus 14 is minus 14? Minus 14. Just use your calculator. Just add all those numbers, add and subtract all those numbers in front of the W's. We're just combining like terms right now. So just use your calculator. Just go minus 35, minus 1, plus 8 plus 14 equals, you get minus 14. Everybody see that? And then finally, 5 minus 112. Is that minus 107?
Yep.
Over, I'm just going to write LCD. All that stuff. It's just that same stuff. We're done. I'm not going to try to factor that top. That's no way. We're done. That is the answer. What did we do? We combined them into one fraction. Does everybody see those steps? So step 1, I factored the denominators. Step 2, I gave them what they're missing, like comparing to your neighbors. I filled in the denominators to make the two denominators the same. I multiplied top and bottom by what was missing to make the two denominators identical. To make the two denominators have the exact same 3 pieces. That was common denominator. Then I was done with the denominator, and I turned my attention to the top. I foiled out both tops and gathered like terms. Big, ugly mess, huh? So a lot of work on that.